Okay, we'll start now. So once again, very good morning. So in the last lecture, we have started the graphical method, that is the Mohr circle method. And in the previous lecture, we have discussed the procedure of Mohr circle. So previous problem, whatever we have solved. So that problem is applicable for the case number 2, because here the member or the body is subjected to the biaxial stresses. So if the sigma x and sigma y is given, how it is represented on the x axis, and what is the procedure to draw the Mohr circle that we have discussed in the previous lecture. Also, whenever we have to go for the calculation of unknown parameters like normal stress, tangential stress, resultant stress, and the angle of obliquity. So, which distances we have to measure actually from the Mohr circle or from that particular drawn figure, that also we have discussed. And to that particular distance, you have to multiply by our selected scale, and you will get your final answers. So this is the graphical method. In addition to that, sometimes in the statement they are asking, that is just verify your graphical answers with your analytical method. So the list of the formulas for the case number 2 and the case number 3, already we have solved the problems based on that. So we are having the list of the formulas. So just you have to verify your answers, whether your graphical answers and the analytical answers are near to each other or not. So somewhat variation it will be accepted, maybe 1 Newton per mm square, 2 Newton per mm square, but it should not be more than 1 or 2 Newton per mm square. So like 5 Newton, the gap between or the error between graphical and the analytical method should not be more. So yesterday we have verified your answers also by using the previous problem. Now in the today's lecture, one more problem we'll solve based on the case number 2. So the statement is given in front of you. So first of all, we'll read the statement carefully and then we'll go for the solution. Okay. The principal stresses are 70 Newton per mm square tensile. So the first stress is given 70 Newton per mm square tensile and 30 Newton per mm square compressive on plane inclined at 30 degree with major principal plane. So the two principal stresses they have given, that is 70 and 30. And I have told, so whatever the first principal stress value is given in the statement, that will be considered as a sigma x, and the second value will be considered as a sigma y. Now here in this particular statement, they have specifically mentioned that 70 Newton per mm square is the tensile, means your sigma x value is tensile and your sigma y value will be compressive. On a plane inclined at 30 degree with major principal plane, find normal, resultant, tangential stress and the phi. In bracket they have given use Mohr's circle method. Means we have to solve this particular numerical by using the graphical method. Okay, so first of all we have to draw the figure. Before that, just we will put or we'll write all the given parameters what is mentioned in the statement. So here sigma x is equal to 70 Newton per mm square in bracket tensile, which is equal to sigma y is equal to minus 30 Newton per mm square in bracket compressive, which is equal to theta is equal to 30 degree. Therefore 2 theta is equal to 60 degree. So this will be, we can take positive because they have not mentioned at which corner your theta will be located, and we have decided if it is not mentioned in the statement, always we have to take at the left side. So as per the sign convention, theta we have taken positive, and we have to calculate normal stress, tangential stress, resultant stress, and angle of obliquity. Okay, so these are all the given parameters. Also, you have to draw the figure. So this is sigma x, which is equal to 70 Newton per mm square. That is sigma x. This is also 70 Newton per mm square. Both are tensile, equal and opposite. Then sigma y is represented along the vertical axis, but it is compressive. Therefore, you have to represent compressive on the figure also. 30 Newton per mm square. Similarly, at the bottom side, 30 Newton per mm square. So this is the value of sigma y. This is the value of sigma y. And theta we have to mention like this. This is theta is equal to 30 degree. So this is the actual figure. The stress distribution of the member, it is given in the form of sigma x and sigma y. Inclination is also given, and we have to calculate the normal stress on the oblique plane, tangential stress on the oblique plane, and then a resultant stress, and the angle between normal and tangential also we have to calculate, that is phi. Angle between normal and the resultant stress, as per the definition, it is the phi angle, that is angle of obliquity. So this is the actual stress distribution. Now here if you see, the sigma x is positive, that is tensile, sigma y is negative. So here you have to represent the sigma y value in the negative region, that is left side of the origin. Because negative stress, negative value you have to represent to the left side of the origin, and the positive values we have to represent at the right side of the origin on the x-axis. So here some figure will be there at the left side of the origin. So try to draw or represent the origin exactly at the center of your notebook. Origin you have to represent at the center of your notebook. So here, after writing the given parameters, so draw the horizontal axis. So this is the horizontal axis. This is the vertical axis. Leave some space at the left side also, leave some space at the right side also. So this is x-x axis, this is y-y axis, and the center point will be considered as a origin. So write on the scale. Once again, same, 1 centimeter is equal to 10 Newton per mm square. So this is the scale we have selected, and accordingly sigma x will be your 7 centimeter and sigma y will be -3 centimeter. So that also you have to write down in the given parameters as per the selected scale, sigma x and sigma y. And then represent the origin point exactly at the center. So by using the selected scale, now you have to represent the position of sigma x and sigma y on the x-axis. Okay, so we have to represent the position of sigma x and sigma y on the x-axis, because both we have to represent on the same. So here, the first value we have to represent, or first point we have to represent, that is point A, correct? What is the sigma x value? 70 Newton per mm square, so 7 centimeter. This is positive, so we have to represent at the right side of the origin, for example, like this. So this is your point A, and at the bottom side, I have told in the previous problem, so you have to represent like this. So sigma x is equal to 70 Newton per mm square, which is equal to 7 centimeter. So this is the point A. The point A represents the position of sigma x from the origin point. It is positive, therefore it is represented at the right side of the origin. Similarly, we have to represent the position of sigma y. Sigma y is negative, that is compressive. So -3 centimeter means we have to represent at the left side of the origin. So that is point between A and B. What is the distance between A and B? 10. Okay. So take the center of the AB, that is point C. From A to B, the total distance is 10 centimeter. From A to B, the total distance is 10 centimeter. So take the center of AB as a 5 centimeter. 5 centimeter from point A, 5 centimeter from point B. So take or locate this point as a C. Locate this point as a C, and by selecting the center point C, draw one circle which is passes through the point B and A. That means either we can select the radius CB or either we can select the radius CA. दोन्हीपैकी कुठली जर एक रेडियस केली तर both are same because C is your center point, and from center point you have to draw one circle which is passes through the point A and B. Which is passes through the point A and B. So draw one circle by selecting the center point C, and that circle will be passes through the point A and B. That circle will be the passes through the point A and B. Now, by selecting the same center point, you have to represent the 2 theta angle by using the protractor. So you have to keep the protractor at point C. Okay. Why we have to take or represent the 2 theta angle by selecting the reference point A? आपण काय केले? Point A ला reference point घेऊन तो anti-clockwise मध्ये 2 theta angle आपण represent केलेला आहे, बरोबर आहे? This is the standard procedure. But why point A? Why not point B? Why point A? Why not point B? Yes, ka? Anti-clockwise. This is the standard. You have to represent the 2 theta angle in anti-clockwise direction only. Okay, but why point A we have selected as a reference? म्हणजे आपण बघा प्रोट्रॅक्टर ह्या पॉइंट सी ला घेऊन आपण ह्या राइट साइड करून आपण असा अँटी क्लॉकवाइज रोटेट करतोय, बरोबर? गेटिंग? बट why point A? So for that purpose we have to check the figure. For that purpose we have to check the figure and we have to check the theta. The concept whatever we have used in the analytical method, same concept we have to use in the graphical method also. So why it is like that? Because if you see your figure, your theta angle is given with major principal plane. Correct? Your theta angle is given in between this major principal plane and inclined plane. And on major principal plane, which stress is there? Whether sigma x is there or sigma y? On major principal plane, whether sigma x is there or sigma y? Sigma x. And what is the position of sigma x? Whether point A or point B? Point A. मग तुमचा थिटा हा मेजर प्रिन्सिपल प्लेनशी दिला असेल तर तो मग कुठल्या पॉइंट पासून घेतला पाहिजे? पॉइंट ए पासून घेतला पाहिजे का पॉइंट बी पासून घेतला पाहिजे? Point A. Why? Because on major principal plane your sigma x is there. That's why in graphical method also we have to select point A as the reference point. Getting? Point A पासूनच काय घ्यायचा 2 theta angle? Because sigma x is represents the point A. Sigma x म्हणजे काय सांगतोय? Point A सांगतोय. And sigma x हा तुमचा major principal plane वर ऍक्ट झाला. So take 2 theta angle 60 degree. Join these 2 points. You will get point D. Okay. So this angle is 2 theta. 2 theta should be in anti-clockwise direction only. 2 theta should be in anti-clockwise direction only from point A. You can write in your notebook at the top. Represent or locate 2 theta angle. Locate 2 theta angle in anti-clockwise direction only. Locate 2 theta angle in anti-clockwise direction only. In anti-clockwise direction only. From point A. From point A only. That is major principal plane. That is major principal plane or sigma x. Point A म्हणजे काय सांगते तुमची position of plane and position of sigma x. So 2 theta is represented. So you will get one point D on the circle, and from that circle, from this particular point D, you have to draw one vertical line in the dotted. You have to draw one dotted vertical line in the downward direction. And in between A to C, you will get one more point, that is point E. You will get one more point, that is point E. Now your circle is over. Now what is your next step? Which points you have to join? Which points you have to join? आता बघा पहिल्या फिगर मध्ये काय झालं होतं, दोन्ही स्ट्रेसेस हे राईट साइडला असल्यामुळे तुमचा ओ पॉइंट हा ए आणि बी च्या अलीकडे आला होता, बरोबर. पण ह्या फिगर मध्ये काय झालेलं आहे, ओ पॉइंट इज इन बिटवीन ए अँड बी, त्यामुळं ओबी डिस्टन्स जॉईन करायचं नाही. यू हॅव टू जॉईन ओडी डिस्टन्स फॉर द सिग्मा आर कॅल्क्युलेशन. गेटिंग OD, so you have to join OD distance by the dotted line. OD distance by the dotted line. So this O to E will be your sigma n, okay. Then this OD will be your sigma r. D to E distance, that is vertical distance. This is your sigma t, and the angle DOE, this is your phi. Angle DOE, this is your phi. Represent all the unknown parameters on the figure. Take point O as a reference line. Don't take point B as a reference line. All the distances we have to measure from the point O, at least for the sigma n and sigma r. Don't take point B as a reference point. This is the point B, means it is the position of sigma y. It is not our origin point. So represent sigma n from O to E, sigma r from O to D, DE as a sigma t, and angle DOE as a phi. Okay. Now we have to measure all the unknown parameters. So from the figure, my first unknown parameter is sigma n is equal to OE into scale. Then sigma t is equal to DE into scale. Third, sigma r is equal to OD into scale. And fourth, phi is equal to angle DOE, which is equal to scale. We have selected 1 centimeter is equal to 10 Newton per mm square. So now measure all the distances from your respective figures and tell me the answers. What is the OE distance? What is the OE distance? Okay, 4.61 answer. Any another answer? 4.6. Okay, any another answer? So represent your answer in the chat box.
5.
From your respective figure. What is your answer? 4.6, 4.5? Whatever answer you got from your respective figure, that you have to write. Maybe 4.5 and 4.6. So many of you got the 4.5, no problem. You can take the 4.5 also. Many of you got the 4.6. You can take the 4.6. So here 4.6 into scale. How much scale we have selected? 1 centimeter is equal to 10 Newton per mm square. So 4.6 into 10 is equal to 46 Newton per mm square. So sigma n is equal to 46 Newton per mm square. Do the separate calculation on the separate page. 46 Newton per mm square. Then DE distance, represent D to E. How much? 4.3. Okay. Any another answer? Okay, 4.3, 4.4. 4.2. So the variation is there from 4.2 to 4.4. Some of you got the 4.2, some of you got the 4.3, some of you got the 4.4. So actually this answer should be same. So due to some errors, that answers are varying. So take the proper distances. So you can take any, whatever you got. So I will take the average, 4.3 into 10. So it is equal to 43 Newton per mm square. 43 Newton per mm square. So now OD distance. 6.3. Okay, 6.3. Okay, 6.3. Any another answer? 6.3 rather than this 6.1. So so much variation is there. Just check it once again. Measure properly. Take the proper points. 6.2, 6.3, or maybe 6.4, like that. So 6.1, 6.2. So there is a gap of near about 2 centimeter. 1 centimeter here and there is no any problem. So how you are drawing that inclined line? So based on that also your answers are vary. So maybe 6.3 or 6.2. So I will take the 6.3 into 10, which is equal to 63 Newton per mm square. So whatever answer you got, you can write, no problem. But try to measure the distances properly. Now what is the angle? DOE?
40.
40. 44. Okay. Then one answer is 45. So 44, 45. 40 is not correct. You have to measure the distance properly. What is your answers? 45. Correct. Either 44 or 45. So this will be correct answer. 40 is not correct. So I will write down the 45 degree. This is the angle of obliquity. So here they have not asked, that is to verify your answers by the analytical method. So don't go for the further calculation, but just for our verification, by using the resultant stress formula, please check resultant of normal stress plus resultant of tangential stress. Check whether it is coming near about resultant of that near about 63. That is 46 square plus 43 square, and then the square root. 62.96 means it is approximately 63. Correct? आपला theoretical formula आपल्याला आहे resultantचा. Resultant is equal to square root of sigma n square plus sigma t square. If you are doing the theoretical calculation, maybe your sigma n will come 45 or 45 point something like this. Then your sigma t will be near about 42 point something or 43 exactly sometimes coming. And त्याचा जरी resultant घेतला तर तुमचा किती येणार आहे? 63 येणार. So your analytical answers will be different and your theoretical answers, that graphical answers will be different. Please keep in mind. Your analytical answers will be different and your graphical answers will be different, but both the answers should be near to each other. At least 1 Newton per mm square gap will be there, no problem. आता तुमचा analytical काय तर 60 येईल, काही जणांचा 64 येईल. So like that variations will be accepted, but the variation should not be more than like 2 centimeter or 3 centimeter like this. आता येतच नाही, तुम्ही कॅल्क्युलेशन कसं जरी केलं तर फक्त तुमचं पॉइंट मध्ये व्हेरिएशन येईल, पण तुमच्या एक्झॅक्ट व्हॅल्यू मध्ये व्हेरिएशन येणार नाही. Okay, so 62.96 it means approximately 63 Newton per mm square. So this is the second variety of the problem where the sigma x will be given as a positive and sigma y will be given as a negative, that is compressive. And how to represent the point B at the left side? Procedure is same, only the position of point C it will get changed. So this is the problem based on the case number 2 where one is tensile, another is compressive. Okay, finish. Everyone have you finished? Everyone have got the answers. So any few students are representing the answers in the chat box. What about others? Have understood, have drawn the figures? So only 2 to 3 replies I got. So near about 47 students are there. So what about others? Okay. So now we'll take the problem based on the case number 3. So one problem just I want to give for the homework also based on the case number 2. So that I will send directly on the your WhatsApp group. The statement I will send on the WhatsApp after finishing this, and then we'll So now we'll move to the case number 3. So the case number 3, we have discussed the analytical methods. That is, the case number 3 represents the member or the body subjected to the biaxial stresses along with shear stress. So now if you see the figure, so in the figure, there is a sigma x, sigma y, and the shear stress also. Getting? So if the problem is given based on the case number 3, then how to draw the Mohr circle? So only small change is there, because now up till now we have used only horizontal axis. Vertical axis चा आपण कुठला point represent केलेला आहे का? नाही. We have represented vertical axis y, but we have not taken any distance along the vertical axis. Now in the case number 3, we have to use your vertical axis also to represent shear stress tau. Okay, so now take the statement in your notebook. At a point in strained material subjected to shear stress shown in figure. So write down this sentence, write down this statement, because this statement is very important. How they are asking the statement, whether it is based on the analytical, whether it is based on graphical, that we have to understand. A strained material subjected to the stresses shown in the figure. Determine tangential and resultant stress. Tangential means sigma t, resultant means sigma r across the oblique plane by the Mohr circle. Means we have to solve this problem based on by using the graphical method. So these words are very important. Either they are giving the graphical word, or sometimes they are using the word like Mohr's circle method. Also determine angle of obliquity and check answers analytically. Also determine angle of obliquity, that means phi, and check your answers analytically. So you have to verify your answers analytically, means you have to solve this numerical by using the analytical problems also. So the figure is given. See the directions of the stresses, because directions plays very important role. So sigma x is given as a 100 Newton per mm square tensile. Sigma y is given 40 Newton per mm square tensile, and the shear stress is also given 20 Newton per mm square. Shear stress is also given 20 Newton per mm square. Angle of inclination with inclined plane and major principal plane already given with vertical plane, so need not require to go for any conversion. So we have to calculate sigma n, we have to calculate sigma t, we have to calculate sigma r, and angle between normal stress and resultant stress will be the phi. Major principal plane, already it is given, inclination is already given with major principal plane or vertical plane. So we can take this 45 as it is, as a theta. Now write down all the given parameters. So sigma x is equal to 100 Newton per mm square in bracket tensile, which is equal to sigma y is equal to 40 Newton per mm square. It is also tensile. Tau is equal to, now please check the shear stress. So which plane we have considered for the sign conventions of the shear stress? Major principal plane. So for the major principal plane, this shear stress is rotating anti-clockwise or clockwise. The shear stress with major principal plane, I am not asking about minor. It is rotating anti-clockwise or clockwise?
Anti-clockwise.
So this is the direction at the bottom side. That means it is anti-clockwise direction. It is also anti-clockwise direction. So shear stress will be positive or negative? Positive. So here plus how much? 20 Newton per mm square, which is equal to theta is equal to already given 45 degree plus, so 2 theta is equal to 90 degree, and we have to calculate sigma n, sigma t, sigma r, and phi. So these are all the given parameters: sigma x, sigma y, shear stress tau. Theta is given plus 45 degree. As per the sign convention, it is positive. So 2 theta is equal to 90. Now the sigma x and sigma y both are tensile. So your maximum diagram will be generated to the right side of the origin. So leave some space, maximum space at the right side of the origin. So once again, you have to draw the vertical axis and the horizontal axis. So this is the horizontal axis. This is your vertical axis. So sigma y or y, then this is x axis. This is the origin point O, right? One scale, 1 centimeter is equal to 10 Newton per mm square. So by applying this scale to the stress values, here sigma x is equal to 10 centimeter, sigma y is equal to 4 centimeter, and shear stress is equal to 2 centimeter. We have selected the scale. 1 centimeter is equal to 10 Newton per mm square. Then draw the horizontal axis, vertical axis, represent the origin point O. Represent the origin point O. So here only small change is there because tau is mentioned in the statement. So how to represent that tau? That we have to understand. Okay. Now first of all, represent the point A. As per the previous procedure, represent point A, that is position of sigma x. See, this is point A. Position of sigma x as a 10 centimeter from the origin point O. So sigma x is equal to 100 Newton per mm square, which is equal to 10 centimeter. Point A means position of sigma x to the right side of the origin because it is positive. Similarly, point B has a position of sigma y. Sigma y is also positive, that is tensile. So you have to represent right side of the origin. Mention this values also. Sigma y is equal to 40 Newton per mm square, which is equal to 4 centimeter. Which is equal to 4 centimeter. Okay. So now up to this process is same. Up to this process is same. Now in the previous two problems, what we have taken, immediately we have taken the center point of ABC, and by selecting the center point C, we have drawn the circle because shear stress is not mentioned. Now here we have to apply the effect of the shear stress also along the vertical axis. Now how to apply it? Just see. Now, what is meant by the point A and what is meant by the point B? So point A represents the position of sigma x, means major principal plane. Correct? Sigma x हा कुठल्या plane वर act झालेला आहे? Major principal plane वर. Similarly, point B represents sigma y, and it is applied on which plane? Minor principal plane. Getting? Now, how to take this reference to represent the shear stress? Now see. The shear stress is rotated in anti-clockwise direction with major principal plane. Shear stress is rotated in anti-clockwise direction with major principal plane. Getting? The shear stress is rotating anti-clockwise direction with major principal plane. Now, this particular shear stress value, that is 20 Newton per mm square, and the 20 Newton per mm square on minor principal plane, we have to represent from the point A and from point B. So before that, you just write down the sign conventions for the graphical method. So write down at the top of your notebook. Write down at the top of your notebook. If shear stress rotates in anti-clockwise direction, if shear stress rotate in anti-clockwise direction to major principal plane, represent it in negative region. Represent it in negative region and vice versa. म्हणजे मेजर प्रिन्सिपल प्लेनला जर शियर स्ट्रेस तुमचा अँटी क्लॉकवाइज असेल तर तो आपण काय कन्सिडर केला या ठिकाणी निगेटिव्ह, आणि मेजर प्रिन्सिपल प्लेनला जर तो क्लॉकवाइज रोटेट होत असेल तर तो काय झाला पॉझिटिव्ह. सिमिलरली अनदर स्टेटमेंट, सिमिलरली if shear stress rotate in clockwise, if shear stress rotates in clockwise, if shear stress rotate in clockwise to minor principal plane, to minor principal plane, to minor principal plane, represent it in positive region, represent it in positive region and vice versa, and vice versa. समजते स्टेटमेंट. नाउ सी आवर फिगर. मेजर प्रिन्सिपल प्लेनला आपला शियर स्ट्रेस कसा रोटेट होतोय, मेजर प्रिन्सिपल प्लेनला आपला शियर स्ट्रेस कसा रोटेट होतोय अँटी क्लॉकवाइज, म्हणजे तो निगेटिव्ह रिजन मध्ये आला पाहिजे. आणि मायनर प्रिन्सिपल प्लेनला 20 न्यूटन पर mm स्क्वेअर कसा रोटेट होतोय मायनर प्रिन्सिपल प्लेनला क्लॉकवाइज. बघा त्याची आरो कुठे आहे, मग हा जर असा मी रोटेट केला तर हा कसा आहे क्लॉकवाइज, तसा खालचा जरी रोटेट केला तर हा कसा आहे क्लॉकवाइज आहे, खालचा पण क्लॉकवाइज. दोन्ही पण सेमच असणार आहे, एकीकडे वेगळा एकीकडे वेगळा असं नसणार आहे. ठीक आहे. मग मेजर प्रिन्सिपल प्लेनचा शियर स्ट्रेस आपल्याला निगेटिव्ह रिजन मध्ये रिप्रेझेंट करावा लागेल आणि मायनर प्रिन्सिपलचा शियर स्ट्रेस कुठे रिप्रेझेंट करावा लागेल पॉझिटिव्ह. ठीक. मग कसा रिप्रेझेंट करायचा तर नाव दिस think about the major principal plane. Now the position of major principal plane and 100 Newton per mm square means your which point A or point B? Position of major principal plane or sigma x म्हणजे तुमचा कुठला पॉइंट आहे पॉइंट A and another is point B म्हणजे 40 Newton per mm square म्हणजे minor principal plane. Getting. Now think about the shear stress which is applied on the major principal plane. बरोबर. मग हा अँटी क्लॉकवाइज रोटेट होते म्हणजे आपल्याला तो निगेटिव्ह रिजन मध्ये रिप्रेझेंट करायला लागेल. मीन्स बाय सिलेक्टिंग पॉइंट ए, हा रिजन कुठला असतो पॉझिटिव्ह. व्हॉट इज दिस निगेटिव्ह. नाउ फॉर मेजर प्रिन्सिपल प्लेन युअर शियर स्ट्रेस इज रोटेटिंग अँटी क्लॉकवाइज डायरेक्शन मीन्स वी हैव टू टेक इट इन नेगेटिव्ह रिजन. मीन्स फ्रॉम पॉइंट ए यू हैव टू ड्रॉ वन वर्टिकल लाइन in downward direction at how much distance? What is the value of shear stress? 20 Newton per mm square. So tau is equal to 20 Newton per mm square, that is equal to 2 centimeter. Getting? Why point A? Why point A? Point A represents the position of major principal plane. Correct? And it is rotated in anti-clockwise. त्यामुळे तो shear stress आपण निगेटिव्ह region मध्ये रिप्रेझेंट केलाय. And that point will be your point. That point will be your point G. or don't represent that point. Afterwards we'll represent, only represent the point. Okay, now जसा मेजर प्रिन्सिपल प्लेन वरचा शियर स्ट्रेस आपण इथे रिप्रेझेंट केला, तसा मायनर प्रिन्सिपल वरचा पण रिप्रेझेंट करावा लागेल. ओके, बट ऍज पर द साइन कन्व्हेन्शन मायनर प्रिन्सिपल प्लेनला तुमचा शियर स्ट्रेस हा क्लॉकवाइज मध्ये जातोय, म्हणजे तो पॉझिटिव्ह रिजन मध्ये आला पाहिजे. म्हणजे फक्त रिजन चेंज होते पण मॅग्नेट्यूड चेंज होते का? इकडे पण 20 न्यूटन पर mm स्क्वेअर आहे आणि इकडे पण 20 न्यूटन पर mm स्क्वेअर आहे. देयरफॉर फ्रॉम पॉइंट बी, हाउ टू ड्रॉ? इट इज रिप्रेझेंट इन द पॉझिटिव्ह रिजन. सो दिस इज positive region point. Draw one vertical line like this, and this is your tau. So tau is equal to 20 Newton per mm square, which is equal to 2 centimeter. So these 2 points you got, correct? Now you can give the name. So this is point G. खालच्या पॉइंट जो आहे त्याला पॉइंट G नाव द्या आणि वरच्या पॉइंटला H नाव द्या. खालच्या पॉइंटला G आणि वरच्या पॉइंटला H. Now join the point G and H by the inclined line. Join the point G and H by the inclined line. So due to that joining, what happened? You will get one more point in between A and B. Correct? इनक्लाइन लाइन ड्रॉ केल्यामुळे तुम्हाला एक पॉइंट मिळेल, त्या पॉइंटला नाव काय द्या? C. What is the BC distance? Can anybody measure? What is B to C distance? 3 centimeter. Okay. Now, by selecting the center point C, don't take radius BC. जी रेडियस आपण केस नंबर 2 ला घेतली होती, बरोबर आहे. डोंट टेक द रेडियस BC, टेक द रेडियस C2H or C2G. टेक द रेडियस C2H म्हणजे काय इन्क्लाइन्ड लाईन आहे, ही इन्क्लाइन्ड लाईन म्हणजे तुमची रेडियस असणार आहे याच्यामध्ये. केस नंबर 2 ला आपल्याला अशी इन्क्लाइन्ड लाईन मिळत होती का? नो, डायरेक्टली वी आर टेकिंग द सेंटर ऑफ AB as a point C in case number 2. बरोबर. and from that center point we are drawing one circle. ते सर्कल पॉइंट A मधून पण जात होता आणि पॉइंट B मधून पण जात होता. Getting? But now here we have to represent the shear stress. We have to join G and H and take the radius CH and CG. So that circle will be passes through the point H and G. ते सर्कल पॉइंट A आणि B मधून जातंय का? That circle will be passing through point A and B because we have changed the radius. So by selecting the center point C, draw the circle which is passes through the point H and G. म्हणजे कुठली रेडियस सिलेक्ट करावी लागणार आपल्याला? either CH or CG. So draw one circle. So that circle will not be passes through the point A and B. That circle will not be passes through the point A and B. मग त्याच्या साइडला तुम्हाला दोन नवीन पॉइंट मिळते सर्कल वर, करेक्ट. सो ऍट वन साइड पॉइंट A च्या शेजारी त्या पॉइंटला नाव द्या पॉइंट P, आणि पॉइंट B च्या शेजारी जो नवीन पॉइंट मिळतोय सर्कल मुळे, that will be your point Q. That will be your point Q. Okay, finish. Select the radius CH. Don't take the radius CB. इथं जर तुम्ही radius CB घेतली तर तुमचे पुढचे आन्सर सगळे चुकणार आहे. So near point A you will get one more point on the horizontal axis, represent point P. तसंच B च्या शेजारी पण एक नवीन पॉइंट मिळतोय सर्कल मुळे, you will get point Q. Now by selecting center point C on the protractor and by taking the reference line as a inclined line, म्हणजे CG, you have to take the CG as a inclined line. You have to take the CG as a inclined line. जसं आपण केस नंबर 2 ला कुठली रेफरन्स लाईन घेत होतो? CA, बरोबर. CA आपण ही इन्क्लाइन्ड लाईन घेत होतो आणि ह्या A पॉइंट पासून आपण अँटी क्लॉकवाइज डायरेक्शन मध्ये 2 थीटा अँगल रिप्रेझेंट. म्हणजे तुम्हाला आता काय करावं लागेल? प्रोट्रॅक्टर पण थोडा तिरका करावा लागेल. गेटिंग? यू हॅव टू रोटेट युअर प्रोट्रॅक्टर. सिलेक्ट द G as a reference point, zero line. सिलेक्ट G ऍज अ 0 लाईन आणि त्या G पासून अँटी क्लॉकवाईज डायरेक्शन मध्ये 2 थीटा अँगल रिप्रेझेंट करा. सिलेक्ट द CG ऍज अ रेफरन्स लाईन, डोंट टेक CA. आणि त्याच्यापासून 2 थीटा अँगल रिप्रेझेंट करा. सो यू विल गेट द फिगर लाईक दिस. आय थिंक 2 थीटा तुमचा किती असणार आहे? 90 डिग्री. करेक्ट. 2 theta is the 90 degree. Don't take A as a reference point. Take G as a reference point. कारण ह्याच्यामध्ये आपल्याला कशामुळे G पॉइंट आपण रेफरन्स पॉइंट घेतलेला आहे? G पॉइंट म्हणजे तुमचा काय सांगतोय? मेजर प्रिन्सिपल प्लेन वरचा शियर स्ट्रेसचा पॉइंट. बरोबर. G पॉइंट काढलाय म्हणजे आपण काय काढलंय? ह्या मेजर प्रिन्सिपल प्लेन वरचा हा शियर स्ट्रेस. करेक्ट. G पॉइंट रिप्रेझेंट्स the position of shear stress on major principal plane. So that's why we have not taken point A as a reference point. जर या ठिकाणी shear stress नसलाच असता तर आपण A point reference point घेतला असता. But here shear stress is also present, therefore we have to take the G as a reference point. So here it is 90 degree. मग तुम्हाला सर्क्युलर एक पॉइंट मिळतो. तो पॉइंट कुठला असणार आहे? हा पॉइंट आपला D. D पासून परत व्हर्टिकल लाईन, डॉटेड लाईन, अँड परत अजून तुम्हाला हॉरिझॉन्टल ऍक्सिस वर E पॉइंट मिळतोय. दॅट इज पॉइंट E. Okay. Now join our points O to D as a dotted line. Take G as a reference point to represent the 2 theta angle. Because this figure or this member is subjected to the normal stresses also as well as shear stresses also. त्यामुळे ह्या ठिकाणी आपल्याला shear stress पासून 2 theta angle represent करायचा आहे. So join the OD distance. Join the OD distance. Represent all the unknown parameters on the figure. O to E हा तुमचा सिग्मा n असणार आहे. O to D, this is your sigma R. Then D to E, sigma T, and angle DOE, this will be the phi. ह्याच्यामध्ये आपले कुठले कुठले पॅरामीटर चेंज झाले? आपला पॉइंट C चेंज झाला. करेक्ट. पॉइंट C we have drawn by joining the inclined line. त्याच्यानंतर पॉइंट C चा सेंटर पॉइंट सिलेक्ट करून आपण CB रेडियस घेण्याच्या ऐवजी CH किंवा CG रेडियस घेतली. and we have drawn one circle. And further process is same, but to draw the 2 theta angle we have taken the reference line as a G or reference point as a G in anti-clockwise direction only. 2 theta angle हा फक्त आणि फक्त anti-clockwise मध्येच रिप्रेझेंट करायचा. So now all the unknown parameters we have represented on the figure. So from figure sigma n is equal to OE into scale. So sigma T is equal to DE into scale. Sigma R is equal to OD into scale. And phi is equal to angle DOE. So 1 centimeter is equal to 10 Newton per mm square. So now represent. So measure all the distances. What is your OE distance? 9. Okay, 9. Any another answer? Measure the O to E distance for the sigma n calculation. Nine centimeter. Correct. Everyone have got 9 centimeters. What about others? Send your answer in the chat box. What is your answer? Whether it is 9 or some 9.1, 9.2 like this. Okay, 9. So 9 into 10 is equal to 90 Newton per mm square. This is sigma n. 9 centimeter is the O to E distance. Then D to E. What is the D to E? 3 centimeter. Okay. D to E for the sigma T calculation, tangential or the shear stress on the inclined plane. 3 centimeter. Please check your answer. Measure the distance from your respective figures. So 3 into 10 is equal to 30 Newton per mm square. 30 Newton per mm square. Then OD distance, O to D for the resultant stress calculation, 9.5. Okay. Any another answer? 9.4. Okay, you can write your answer 9.4 or 9.5. Both are accepted, no problem. So 9.5 or 9.4, you can write anyone from your respective figures. So 95 Newton per mm square. 9.4 or 9.5. And then measure the angle DOE. 18. Okay. So after 18, if your that line is between 18 and 19, that also we can consider like 18.5 or 19. आपण 18.43 म्हणू शकत नाही कारण आपल्याला माहित नाही त्या दोन्ही मध्ये डिस्टन्सेस. If your that line is crosses more than 18, so you can write down 18.5 also. Slightly it is no problem. So 18.5 you can write like this. If exactly it is 18, then you can write 18. If exactly it is 19, you can write down 19. But if there is some distance after 18 or 19, you can write down like 18.5. So approximately it will be considered as a 19. So maybe some of you got the answer like 18.5 degree. Some of you got 18 degree, or some of you got the 19 degree. So 18.18 or 18.5 or 19, it will be accepted because this is the graphical method. So exact answer will not be possible. Okay, finish. Have got all the answers. Have done the calculations. Okay. Now we'll take one more problem. So actually statement is not with me. I will dictate the statement. You just write down in your notebook. I will give the figure also. Write down. A point in strained material. A point in strained material subjected to. A point in strained material subjected to stresses shown in figure. Subjected to stresses shown in figure, full stop. Find graphically normal, shear, and resultant stress on AB. Normal, shear, and resultant stress on AB, full stop. Also find angle of obliquity. Also find angle of obliquity. Okay. Now the figure I will draw here, you can take in your notebook. Draw this figure. Sigma x is equal to 75 megapascal. Sigma y is equal to 150 megapascal. So this is point A, this is point B. So angle is given with minor principal plane. Go to the angle 55 degree. Then shear stresses are also given. That is 20 megapascal. So this is the figure. So in the figure, what they have given, sigma x is given as a tensile, which is equal to 75 megapascal. Sigma y is given again tensile, but value is maximum as compared to sigma x, that is 150 megapascal. And then the angle of inclination is also given, that is inclined plane AB. But angle is given with minor principal plane. Whether it is given with major principal plane, no, but we have to convert it. And the shear stresses are also given with major and minor principal plane. So we have to check their direction clockwise and anti-clockwise while drawing the circle. Okay, so first of all, we write down the given parameters. You will get understood from this. So given sigma x is equal to 75 Newton per mm square, megapascal means Newton per mm square. Both are tensile. Then sigma y is equal to 150 Newton per mm square. It is also tensile. Tau is given 20 Newton per mm square, which is equal to theta is given 55 degree with minor principal plane. Therefore, theta is equal to, this is 90 degree, correct? So 90 minus 55, how much? 45 or 35? 35 degree. Therefore, 2 theta is equal to 70 degree. So here your actual theta value as a 35 degree. आणि याच्यावरचे आपल्याला सिग्मा n फाइंड आउट करायचा आहे, याच्यावरचं सिग्मा t फाइंड आउट करायचा आहे, याच्यावरचं रिझल्टंट फाइंड आउट करायचा आहे आणि नॉर्मल आणि रिझल्टंट मधला अँगल म्हणजे तुमचा फाय असणार. So this is the actual figure and we have to calculate sigma n, sigma t, sigma r and phi. Getting? So these are the given parameters. Try to convert the theta. If you are not converting theta in major principal plane and you are making or you are using this 55 into 2, that is 110, your answers will be wrong. So please check the theta properly, whether it is with our required plane or not. Now here we can, in front of 35 degree, you can write with vertical plane. Now follow our procedure, draw vertical axis, horizontal axis. So x axis, then y, then origin O. Select the scale. 1 centimeter is equal to 10 Newton per mm square or megapascal. So as per the dimensions, your sigma x is equal to 7.5 centimeter, sigma y is equal to 15 centimeter, and tau is equal to 2 centimeter. The sign conventions for the graphical and analytical method for the shear stress is totally different. Have understood? आपण एनालिटिकल मध्ये मेजर प्रिन्सिपल प्लेनला जर अँटी क्लॉकवाइज असेल तर एनालिटिकल मध्ये आपण तो टाउ निगेटिव्ह घेतलेला आहे, बरोबर का पॉझिटिव्ह घेतलाय? एनालिटिकल मेथड मध्ये आपण शियर स्ट्रेस हा मेजर प्रिन्सिपल प्लेनला जर अँटी क्लॉकवाइज रोटेट होत असेल पॉझिटिव्ह घेतलेला आहे, आणि इथं कसं घेतलं ग्राफिकल मेथड मध्ये अँटी क्लॉकवाइज निगेटिव्ह घेतलेला आहे, करेक्ट? So there is a small change in graphical method actually, because here origins are there. कुठला region positive आहे, कुठला region negative आहे. So this is positive region, this is negative region. So first of all represent point A. What is point A? Sigma x. So from origin point it is tensile, so here it is coming 7.5 centimeter, correct? This is point A. So sigma x is equal to 75 Newton per mm square, which is equal to 7.5 centimeter. Correct? Then from point O, again you have to represent the sigma y. At the point A ha point B च्या पुढे जाणार आहे, because it is 15 centimeter. So here this is your point B. It is also right side of the origin because both are tensile. So here your sigma y. Sigma y is equal to 150 Newton per mm square or megapascal, which is equal to 15 centimeter. So point A is represented, point B is represented. Getting? Don't take the center of AB because shear stress is there, correct? Point A आणि B पासून आपल्याला shear stress अगोदर ड्रॉ करावा लागेल. Now please tell me, now think about shear stress which is applied on major principal plane. आता major principal plane ला तुमचा shear stress हा clockwise rotate होतोय का anti clockwise rotate होतोय? Think about only major principal plane. It is rotated clockwise, so we have to take positive or negative. Check the sign convention. काय दिलं तिथं vice versa. Vice versa म्हणजे काय? जर क्लॉकवाइज असेल तर पॉझिटिव्ह रिजन मध्ये. इथं मी स्टेटमेंट मध्ये काय दिलं होतं मगाशी बघा. If shear stress rotate in anti-clockwise direction to major principal plane, represent it in negative region and vice versa. म्हणजे जर तो मेजर प्रिन्सिपल प्लेनला क्लॉकवाइज मध्ये रोटेट होत असेल तर तो कुठल्या रिजन मध्ये येणार? पॉझिटिव्ह रिजन मध्ये येणार. मग पॉइंट ए पासून what is the magnitude of shear stress? 20 म्हणजे 2 सेंटीमीटर. पॉइंट ए पासून मला पॉझिटिव्ह रिजन मध्ये व्हर्टिकल लाईन काढावी लागेल का निगेटिव्ह रिजन मध्ये? पॉझिटिव्ह रिजन मध्ये. सो ड्रॉ वन व्हर्टिकल लाईन फ्रॉम पॉइंट ए. ड्रॉ वन व्हर्टिकल लाईन फ्रॉम पॉइंट ए. So this is point G, which is equal to tau is equal to 20 Newton per mm square, which is equal to 2 centimeter. The sign conventions for the graphical method and analytical methods are different. Similarly, point B ला म्हणजे मायनर प्रिन्सिपल प्लेनला तुमचा शियर स्ट्रेस हा अँटी क्लॉकवाइज का क्लॉकवाइज आहे? मायनर प्रिन्सिपल प्लेन म्हणजे कुठले? टॉप अँड बॉटम. मग त्याला हा शियर स्ट्रेसचा आरो कुठे इकडे आहे. मग ही डायरेक्शन कशी झाली रोटेशनची? अँटी क्लॉकवाइज. त्याची खालची पण कुठली झाली? मग अँटी क्लॉकवाइजला काय घ्यायचं? पॉझिटिव्ह का निगेटिव्ह? निगेटिव्ह. म्हणजे पॉइंट बी पासून शियर स्ट्रेस हा तुम्ही निगेटिव्ह रिजन मध्ये रिप्रेझेंट केला पाहिजे लाईक दिस. सो दिस इज पॉइंट एच. So tau is equal to 20 Newton per mm square, which is equal to 2 centimeter. And then join point G and H. You will get one point C in the center of AB. म्हणजे सेंटर काढण्यासाठी आपल्याला अगोदर शियर स्ट्रेसेस काढावे लागतील. तसं केस नंबर 2 मध्ये आपण डायरेक्ट ए आणि बी चा सेंटर घेतोय. पण केस नंबर 3 मध्ये शियर स्ट्रेसेस काढून ते दोन पॉइंट जॉईन करून ऑटोमॅटिक तुम्हाला सी पॉइंट जनरेट होतो. So understand the difference between case number 2 and case number 3 for the graphical concepts. Then by selecting the center point C and taking the radius CG or CH. Correct? Take the inclined radius. Don't take CA or CB radius. तुमचे circle G किंवा H मधूनच pass झालं पाहिजे. So by selecting the radius CG and CH, draw the circle which is passes through the point G and H. Here circle is not looking in my figure, it is looking like ellipse. But I hope in your figures there will be circle only. Draw the circle which is passes through the point G and H. So that circle will not pass through the point A and B. Now, by putting your protractor at point C, and by taking the reference point as a G, your reference line as a GC, represent 2 theta in anticlockwise. म्हणजे कुठून पण येणार आहे बघा. हा म्हणजे तुमचा झिरो लाईन प्रोट्रॅक्टर तुम्ही इथे म्हणजे प्रोट्रॅक्टर आय थिंक यू हॅव टू कीप ॲट पॉइंट सी इन इन्व्हर्टेड मॅनर. तुम्हाला उलटा ठेवावं लागेल. बरोबर का? We have to represent the 2 theta angle in anti-clockwise direction. म्हणजे प्रोट्रॅक्टर तुम्हाला उलटा ठेवावा लागेल बघा. म्हणजे तुमचा पॉइंट जी ला तुमची झिरो लाईन आली पाहिजे. पॉइंट जी ला तुमची झिरो लाईन आली पाहिजे. हॅव अंडरस्टूड? समजतोय कसा ठेवायचा आहे? नो. समजतं का प्रोट्रॅक्टर कसा ठेवावा लागेल? उलटा. म्हणजे त्या प्रोट्रॅक्टरचा सेंटर पॉइंट सी ला आला पाहिजे आणि तिची काही झिरो लाईन असते खालची प्रोट्रॅक्टरची ती कुठं असली पाहिजे? तुमच्या जी कडे. करेक्ट? आणि तिथून तुमचा 2 थीटा अँगल किती असणार आहे? 2 थीटा अँगल तुमचा 70 डिग्री. म्हणजे हिअर यू विल गेट 1 पॉइंट लाईक दिस. बघा मी इथे ड्रॉ केले फिगरवर. दिस इज युअर 2 थीटा. म्हणजे हा पॉइंट डी इथं मिळतोय तुम्हाला. बरोबर? खालच्या बाजूला पॉइंट डी मिळतोय. निगेटिव्ह रिजन मध्ये पॉइंट डी मिळतोय. हॅव गॉट? Yes, those who are attending online, have you got how it is represented 2 theta angle in anti-clockwise direction? And from point D, there is a vertical line, dotted vertical line, and you will get 1 point E once again. Please keep in mind, so while representing the 2 theta, you have to represent in anti-clockwise direction only. And in case number 2, your point A will be the reference point. And in case number 3, which point will be the reference point? Point G. Point G will be the reference line or reference point. तुम्ही जर पॉइंट सी वर ठेवला आणि पॉइंट जी मध्ये जर तिकडच्या बाजूला रिप्रेझेंट करत होतो की तुमचा तो तिकडे कुठे जातोय? वरच्या बाजूला जातोय. You have to keep your protractor in inverted manner. And you have to represent the 2 theta angle. And now join the remaining points, whatever you got. So join the OD distance by the dotted line. So that will be your sigma r. Then OE distance. OE distance will be the sigma n. Then D to E distance. This will be your sigma t. सगळे अननोन पॅरामीटर फिगर वर ड्रॉ करा. सिग्मा टी and angle DOE will be your phi. And from the figure, measure all the distances. So from figure, so first sigma n is equal to O to E into scale. Sigma t is equal to D to E into scale. 3 sigma r is equal to OD into scale. And fourth, phi is equal to angle DOE is equal to. So what is your OE distance? OE is equal to 8.1. Okay, one answer is 8.1. Any another answer? 8.2. So 8.1, 8.2 or 8. Please check from your respective figures. So I will take 8.1 into 10 is equal to 81 Newton per mm square. So this will be the normal stress. Then sigma t 2.8. So here, if you measure the sigma t, it is in negative region. Whatever. So here minus 2.8 into 10 is equal to minus 28 Newton per mm square. Then sigma r 8.5. 8.5. So what is your answers, others? 8.5 into 10 is equal to 85 Newton per. What is your answer? Sigma t and sigma r. What is your distances? Send your answers in the chat box. Whether it is near about this. Okay, 8.2 is one answer. Another D distance for the sigma t calculation. Okay, 8.6 also correct, no problem. 8.5, 8.4, 8.6. And what is the angle? 19 degree. So maybe some of you got 19 degree. Some of you got 19.5 degree. Some of you got 20 degree. Please check and verify your answers. So this particular measuring the dimensions, measure the dimensions properly. Yes, have got okay, 19 or 19.5 or 20 degree. Okay, so this is about the case number 3. Have you understood the procedure? I've got the difference. So once again, I want to tell for the case number 2, sigma x and sigma y is there, and the procedure is very simple. I think as compared to the case number 3, case number 2 is simple because we are taking the reference point C as the center of AB, and by selecting that radius only we are drawing the circle. Fitting? And point A will be the reference point to represent the 2 theta angle. Correct? But in case number 3, we have to represent the shear stress also from point A and B. Then we are drawing the inclined line. Due to that inclined line, you will get point C. Due to this inclined line, you will get point C. And by selecting the inclined radius, we are drawing the circle. Only this is difference is there. Otherwise, further process 2 theta angle, we have to take the reference point as a G, because your major principal plane, it is also subjected to the shear stress. So here we have taken the G as a reference point in anti-clockwise direction, and then by joining the points and by measuring the unknown parameter, unknown distances, and by multiplying the scale, you will get the correct answer. So now, why this Mohr circle will not be applicable for the case number 1? Why the Mohr circle will not be applicable for the case number 1? By solving the problems on case number 2 and 3, why it is not applicable for case number 1? मग down असला तर case number 2 is sigma y. Sigma y is not given in case number 1. What is our case number 1? Member or body subjected to the uniaxial stress. Uniaxial म्हणजे so if sigma y value is not given, then are you able to represent the point B? तुम्ही point B represent करू शकता का? नाही. मग point B जर तुमच्याकडे नसेल तर are you able to draw the circle? फक्त point A चा वापर करून किंवा दुसरीकडे कुठला तर सेंटर पॉइंट, जसं केस नंबर 2 मध्ये आपण AB चा सेंटर घेतोय, केस नंबर 3 मध्ये आपण A आणि B पासून शियर स्ट्रेस काढून इन्क्लाइंड लाईन करून परत तुम्हाला पॉइंट C मिळतोय, म्हणजे ऑटोमॅटिक सेंटर मिळतोय. बट इन केस नंबर 1 फक्त एकच व्हॅल्यू आहे आपल्याकडे सिग्मा x, आणि फक्त सिग्मा x म्हणजे पॉइंट A काढून आपण मोर सर्कल ड्रॉ करू शकतो का? So it is not applicable for the case number 1. So in case number 2, case number 3, at least you will get the center points, so we can draw the Mohr circles, and by using that we can find out the unknown parameters. So maximum times. So for case number 2 and 3, the your graphical method and the Mohr circle method will be applicable. Understood both the procedures? Understood the sign conventions? Sign conventions of the shear stress in analytical method and in graphical methods are different. ग्राफिकल मेथड मध्ये आपण नॉर्मली अँटी क्लॉकवाइज असेल तर तो निगेटिव्ह रिजन मध्येच रिप्रेझेंट करतो, आणि क्लॉकवाइज असेल तर तो पॉझिटिव्ह रिजन मध्ये रिप्रेझेंट करतोय. पण अॅनालिटिकल मेथड मध्ये अपोजिट आहे. अँटी क्लॉकवाइज आपण पॉझिटिव्ह घेतले, क्लॉकवाइज आपण निगेटिव्ह घेतले. पण अॅनालिटिकल मेथड मध्ये आपण रेफरन्स हा फक्त आणि फक्त मेजर प्रिन्सिपल प्लेनलाच घेतलेला आहे. समजतंय? अॅनालिटिकल मेथड मध्ये आपण टाऊचा विचार करताना कधी मायनर प्रिन्सिपल प्लेनशी तो कंपेअर केलाय का? नाही, फक्त मेजर प्रिन्सिपल. Otherwise, for the graphical method, both the sign conventions I have given in your notebooks as an important note, so you can refer it while drawing the figure. Okay, and with this we have finished this chapter number 3, that is principal stresses and the stress. So here no any other variety is there. So same problem we have to solve by using the analytical method, and problems we have to solve by using the graphical method. Stage parameter काढायचे. Only we have to read the statement. But for the graphical method, they are mentioning the word मध्ये सॉल्व अॅनालिटिकली, म्हणजेच तो प्रॉब्लेम तुम्हाला फक्त आणि फक्त अॅनालिटिकल मेथडनं सॉल्व करायचा आहे. जर ग्राफिकल न दिला असेल तरच ते वर्ड मेन्शन करतील, यूज मोर सर्कल मेथड, यूज ग्राफिकल मेथड, फाइंड ग्राफिकली like this, and verify your answers analytically like this. Okay, so with this we have finished this chapter. Anybody any problem for this chapter number 3? Understood all the concepts? Only you have to remind the list of the formulas. फक्त ग्राफ अॅनालिटिकल मेथड मध्ये तुम्हाला सिग्मा एन आणि सिग्मा टी चे फॉर्म्युला रिमाइंड करावे लागतील, and that is very simple for reminding. तुम्ही पहिला केस नंबर 1 चा फॉर्म्युला लक्षात ठेवला की त्याचंच एक्सटेन्शन केस नंबर 2 ला इन द फॉर्म ऑफ सिग्मा वाय. तुम्हाला केस नंबर 2 चा फॉर्म्युला माहित असेल तर त्याचंच एक्सटेन्शन केस नंबर 3 ला इन द फॉर्म ऑफ टाउ, तेवढंच एक्सटेन्शन झालं आहे. अदरवाइज सिग्मा आर, फाय and tau max, that 3 formulas are same. Understood? Okay, so those who are attending online have understood this chapter. Any problem? Okay, what about others? Have understood everyone? Any problem? You can ask. So one problem, I will give the homework for the case number 2 that I will send on the WhatsApp. Case number 2 is like homework problem I will send on the WhatsApp group. So that you have to solve and send the solutions to me. Okay. So with this, today we will stop here. In the next lecture, we will start with the next chapter, that is last chapter.